At 04:37 hours on October 25, 1943, Sergeant Daniel Morrison sat in the radio operator's compartment of a B-17G nicknamed Lady Liberty, flying through freezing fog over the North Sea, listening to his radio equipment slowly die. The SCR-274N radio system, the lifeline that connected bombers to their bases, to fighter escorts, to each other, was failing the same way it had failed on 11 previous missions Morrison had flown, and the same way it had failed permanently on 7 B-17s that never made it home. Morrison was a radio operator with the 381st Bomb Group, stationed at Bassingbourn in England. 31 years old, electrical engineer before the war, 5'9", thin from flight rations and stress. He'd flown 28 combat missions over Germany and occupied Europe. On 19 of those missions, his radio had experienced partial or complete failure due to moisture infiltration at altitude. The problem was simple physics. At 25,000 feet, temperatures dropped to minus 40 degrees Fahrenheit. The B-17's unpressurized interior was barely warmer. When bombers climbed through clouds and fog, which was constant over England and the North Sea, moisture accumulated inside the aircraft. That moisture condensed on cold surfaces, froze, then melted again as altitude changed. Water infiltrated everything: equipment housings, electrical connections, vacuum tubes, antenna systems. The SCR-274N radio was particularly vulnerable. The system consisted of multiple components mounted throughout the aircraft: transmitter, receiver, command set, liaison set, all connected by cables running through the fuselage. The radio operator's position was located in the fuselage just aft of the bomb bay. Cold air blasted through gaps around the bomb bay doors. Moisture condensed on the radio equipment constantly. When moisture infiltrated the transmitter, electrical arcing occurred across components. Vacuum tubes failed, connections corroded. The transmitter's output power dropped from 70 watts to 20 watts, then 5 watts, then nothing. The receiver suffered similar degradation. Static increased, signal strength decreased. Eventually, the radio operator could neither transmit nor receive. A bomber without radio was isolated, vulnerable, lost. It couldn't receive navigation updates, weather information, or recall orders. It couldn't call for fighter escort or request emergency assistance. If damaged, it couldn't communicate its position for rescue. Over the North Sea, 600 miles of freezing water between England and targets in Germany, radio failure often meant death. Morrison had watched it happen repeatedly. On September 14th, the B-17 named Heaven's Gate lost radio contact during a mission to Bremen. The aircraft disappeared. Search aircraft found nothing. All 10 crew presumed dead. On September 23rd, Yankee Rebel experienced radio failure over the North Sea, couldn't receive the emergency diversion signal. When weather closed, Bassingbourn ran out of fuel trying to find the base, ditched in the English Channel. 4 crew survived, 6 drowned. October 2nd, Carolina Bell lost radio during a mission to Hamburg, couldn't call for help when 2 engines failed, crashed attempting an emergency landing at a coastal airfield, 9 dead. October 9th, Memphis Lady experienced complete radio failure, flew off course, ended up over Denmark, shot down by flak, all killed or captured. Morrison reported the pattern to Major William Bradford, the group communications officer. Bradford said moisture infiltration was a known issue, that radio maintenance crews were addressing it, that field modifications weren't authorized. Morrison explained that maintenance crews were overwhelmed. 360 bombers at Bassingbourn, only 12 radio technicians, each aircraft requiring hours of work after every mission. By the time maintenance crews dried out and tested radios, the aircraft were flying again, accumulating more moisture. Bradford said the radios were built to military specifications. If they failed, it was a training or maintenance issue, not a design flaw. Morrison should focus on proper operation procedures. Morrison knew that was bullshit. He'd been an electrical engineer at Westinghouse before the war, worked on industrial radio systems, understood how moisture affected electronics. The SCR-274N wasn't designed for the extreme conditions of high-altitude bombing over Northern Europe. Nobody had anticipated bombers flying through freezing clouds for 8 hours straight, that moisture would infiltrate sealed housings, that condensation would destroy electrical components. The solution wasn't better maintenance or training, it was physical modification. Waterproofing the equipment, sealing connections, preventing moisture infiltration in the first place. Morrison started designing modifications in his head during missions. He'd sit at his radio position, watching condensation form on the equipment housings, seeing water droplets run down cables, and think about how to stop it. He sketched ideas in a notebook: sealed housings, waterproof cable connections, drainage systems for condensed water. On October 12th, after a mission where his radio had operated at 30% capacity due to moisture, Morrison approached Technical Sergeant Mike O'Reilly at the radio maintenance shop. O'Reilly was one of 12 technicians responsible for maintaining radio equipment on 60 B-17s. He looked exhausted, working 16-hour days trying to keep radios functional. Morrison showed O'Reilly his sketches, explained his waterproofing concept, seal the radio housings with rubber gaskets, coat electrical connections with waterproof compound, install condensation drains that would allow water to escape without reaching electronics. O'Reilly studied the drawings. This would work. Problem is, we don't have authorization to modify radio equipment. These sets are classified. Unauthorized modifications could get us both court-martialed. Men are dying because the radios fail, Morrison said. I know, I've seen the loss reports, but I can't help you officially. What about unofficially? O'Reilly looked around the maintenance shop. Other technicians were working on disassembled radios, testing components, replacing tubes. Nobody was paying attention. There's rubber gasket material in the supply room. Nobody's tracking it closely. There's also waterproof electrical compound in the cabinet by the door. If some of that material went missing, I probably wouldn't notice. Morrison nodded. What about tools? Tool room closes at 2200. If someone wanted to work after hours, they'd need to bring their own tools. I wouldn't know anything about it. Understood. Morrison acquired materials over the next 2 days. Rubber gasket material from the supply room, waterproof compound from the maintenance cabinet, a small electric drill and hand tools from a sympathetic crew chief who asked no questions. He stored everything in his barracks footlocker. On the night of October 15th, Morrison approached Staff Sergeant Frank Chen, Lady Liberty's top turret gunner. Chen had been a mechanic in San Francisco before the war, knew his way around tools and machinery. Morrison explained the radio waterproofing plan, asked if Chen would help. Chen said yes immediately. I've been in 3 aircraft that lost radio over water. Scared the hell out of me every time. If you can fix it, I'll help. They worked on Lady Liberty after 2,300 hours, when the flight line was mostly empty. Morrison removed the access panels on the radio equipment, examined the transmitter and receiver housings. Moisture had corroded several connections. Water stains marked the interior of the housings. Morrison and Chen disassembled the radio system completely, cleaned every component, dried everything thoroughly. Then they began modifications. First, rubber gaskets cut to size, installed between housing covers and bases. The gaskets created waterproof seals that prevented moisture infiltration. Second, all electrical connections coated with waterproof compound. The compound prevented water from reaching bare metal, stopped corrosion. Third, small drainage holes drilled in the bottom of each housing, positioned so condensation could drain away from electronics. The modifications took 6 hours. By 0500, they'd reassembled the radio system with waterproofing installed. Morrison tested the transmitter and receiver. Both functioned normally. Now they needed to see if the waterproofing would hold up at altitude under real conditions. Lady Liberty flew a mission to Bremen on October 18th. Morrison monitored his radio equipment throughout the flight. They climbed through 15,000 feet of cloud and fog. At 25,000 feet, the temperature was minus 38 degrees. Moisture condensed everywhere inside the aircraft, froze on metal surfaces, created ice crystals that drifted through the fuselage, but the radio equipment stayed dry. Morrison checked the housings every 30 minutes. No moisture inside. The gaskets held. The waterproof compound protected the connections. The drainage holes allowed condensed water to escape before reaching electronics. The radios functioned perfectly for the entire 8-hour mission. Transmitter output remained at 70 watts. Receiver sensitivity stayed strong. Morrison maintained clear communication with the formation, received navigation updates, coordinated with the lead bomber without any degradation. When they landed at Bassingbourn, Morrison opened the radio housings to inspect. The interior was dry. No condensation, no water stains, no corrosion. The waterproofing worked. He showed the results to Chen. The turret gunner said, "You need to put this modification on every airplane in the group. It's unauthorized. Major Bradford already told me field modifications aren't approved. Bradford's not flying over the North Sea with a failing radio. We are. Fuck his approval." Morrison thought about the 7 aircraft lost due to radio failure. 70 men dead or missing. He thought about more missions coming, more aircraft flying through freezing fog, more radios failing because moisture destroyed the electronics. He made his decision. "I'll need help. We can't waterproof 60 aircraft by ourselves." "I know 3 other mechanics who'll help," Chen said. "They've all lost friends to radio failures. They'll do it without asking questions." Over the next week, Morrison and Chen recruited 4 more crew members, 2 mechanics, a radio operator from another crew, an engineer who'd worked at RCA before the war. They formed an unofficial modification team, working after hours, avoiding attention from officers. The team developed an assembly line process. Morrison would identify aircraft with the worst radio problems. The team would work on one aircraft per night, completing the waterproofing in 4 to 5 hours. They scavenged materials from damaged aircraft, stockpiled rubber gaskets and waterproof compound, shared tools. By October 24th, they'd modified radio equipment on 17 B-17s. The aircraft with waterproofed radios showed 0 failures during missions. Aircraft with standard radios continued experiencing moisture-related failures at rates of 30% to 40%. The success pattern was obvious to anyone paying attention. Crews flying aircraft with modified radios requested those aircraft specifically. Pilots asked why some radios worked perfectly, while others failed constantly. On October 20th, Major Bradford noticed the pattern. He ordered an inspection of Lady Liberty's radio equipment. Found the gaskets, the waterproof compound, the drainage holes. Realized the modifications had been done without authorization. Bradford summoned Morrison to his office. Morrison stood at attention while Bradford examined photographs of the modified radio equipment. "Sergeant Morrison," Bradford said, "you've modified classified radio equipment without authorization." "Yes, sir." "Do you understand this is a serious violation?" "Yes, sir." "Then why did you do it?" Morrison met Bradford's eyes. "Because 7 aircraft have been lost due to radio failure in the past 6 weeks, sir. 70 men dead or missing. The waterproofing modifications prevent moisture infiltration. Aircraft with modified radios have 0 failures. I chose to save lives rather than wait for official approval." Bradford set down the photographs. "You chose to violate regulations and risk court-martial." "Yes, sir, I did." The room was silent for a long moment. Then Bradford said, "How many aircraft have you modified?" 17, sir." "And the failure rate on those aircraft?" 0 radio failures due to moisture in 43 missions, sir." Bradford leaned back in his chair. "Sergeant, you've put me in a difficult position. I can't officially approve unauthorized modifications, but I also can't ignore a modification that's preventing equipment failures and saving lives." He paused. "Remove the modifications from all 17 aircraft. Return the radios to standard configuration." Morrison felt his chest tighten. "Sir, if we remove the waterproofing, the radios will fail again. Men will die. That's not your decision to make." "With respect, sir, it's exactly my decision. I'm the one sitting at that radio when it fails. I'm the one who can't call for help when we're shot up over the North Sea. I'm the one who—" "You're dismissed, Sergeant." Morrison saluted, left the office, walked back to Lady Liberty's hardstand. His crew was waiting. Chen asked what happened. Morrison explained Bradford's order. "Are you going to comply?" Chen asked. Morrison looked at the B-17, at the radio antennas that connected them to the world during missions. He thought about the mission scheduled for tomorrow, a long-range strike to targets near the Baltic Sea, 8 hours over water. If radios failed, crews would be on their own. "No," Morrison said. "I'm not removing the modifications." Chen nodded. "Good. Neither are we." Part 2. The mission briefing on October 25th revealed the target, Anklam, a Focke-Wulf aircraft factory on the Baltic coast of Germany. Maximum range for B-17s, 800 miles over water and enemy territory. Expected flight time, 9 hours. Fighter escort only for the first 200 miles. Heavy flak anticipated over the target. Weather forecast, dense cloud cover from sea level to 20,000 feet. Morrison sat in the briefing room and felt his stomach tighten. This was exactly the type of mission where radio failures killed crews. Long duration over water, no visual navigation possible through clouds. Complete dependence on radio for position updates and weather information. If radios failed, bombers would be flying blind over 600 miles of ocean. Lieutenant Hayes, Lady Liberty's pilot, found Morrison after the briefing. "Doc, I heard Bradford ordered you to remove the radio modifications." Morrison nodded. "Yes, sir." "Did you remove them?" "No, sir." Hayes was quiet for a moment. "Good. I trust your equipment more than standard issue. We're going to need working radios today." At 0700 hours, 36 B-17s from the 381st Bomb Group took off from Bassingbourn and climbed into gray clouds. Lady Liberty was flying number 5 position in the lead squadron. Morrison settled into his radio position, checked his equipment, confirmed communication with the formation leader and base operations. They climbed through 18,000 feet of solid cloud. Moisture condensed everywhere. Ice formed on the windows, the gun barrels, every exposed metal surface. Morrison watched water droplets appear on the standard radio housings of adjacent equipment, saw moisture accumulate around cable connections, but his modified radio equipment stayed dry. The gaskets sealed the housings. The waterproof compound protected the connections. The drainage holes allowed condensed water to escape harmlessly. At 25,000 feet, they broke through the clouds into clear sky. Temperature, -41 degrees. Morrison's breath froze in the air. He wore electrically heated gloves, but his fingers were still numb. He keyed his transmitter, checked in with the formation. His radio transmitted clearly, 70 watts output, perfect clarity. Over the next 2 hours, Morrison monitored radio traffic from the formation. Several aircraft reported radio problems. Weak signals, static, intermittent transmission, the standard pattern of moisture-related failures. Lady Liberty's radio continued functioning perfectly. At Aero 923, they crossed the German coast near Rostock. Flak started bursting around the formation, black puffs of smoke close enough that Morrison heard the explosions over the engine noise. A B-17 named Devil's Brigade took a direct hit, fell out of formation trailing smoke. Morrison heard the pilot's emergency call on the radio, then silence. The bomber disappeared into the clouds below. At 0947, German fighters appeared, FW-190s and Me-109s, maybe 40 aircraft, attacking the formation in waves. The bomber gunners opened fire. The sound was deafening. 10 50 caliber machine guns per bomber, 36 bombers, all firing simultaneously. Spent shell casings rained through the fuselage. Smoke filled the aircraft. Morrison stayed at his radio position, maintaining communication with the formation leader. 2 more bombers were hit by fighters, fell away damaged. The formation tightened up, closed the gaps, continued toward target. At 1008, they reached Anklam. The bombardier called bombs away. Morrison felt Lady Liberty lift as 4,000 pounds of bombs dropped toward the factory below. The formation turned for home, heading northwest toward the Baltic Sea. That's when things started going wrong. At 10:34, the formation leader's radio failed, complete transmission loss. The deputy lead tried to take over navigation, but his radio was experiencing severe static. Morrison could barely hear the transmissions. Other aircraft were reporting radio problems. Multiple bombers had lost communication completely. Hayes's voice came over the intercom. "Doc, are we still transmitting?" Morrison keyed his microphone. "Yes, sir. Radio functioning normally." "Can you contact base operations?" Morrison tried. The distance was too great for direct communication. They were 600 miles from England. But he could relay through RAF coastal stations. He tuned to emergency frequency. Transmitted, "Royal Air Force Coastal Command, this is U.S. Army Air Force formation over Baltic Sea, requesting relay to Bassingbourn operations." A British operator responded immediately. "American formation, this is RAF Bircham Newton, ready to relay." Morrison provided their position, heading, status. The RAF operator relayed the information to Bassingbourn. Base operations responded with weather update, heavy fog moving into England, visibility dropping rapidly. All aircraft should be prepared for instrument approaches. Morrison relayed the weather information to Hayes. Then he tried to transmit to other aircraft in the formation. Most weren't receiving. Their radios had failed. Only 7 B-17s out of the original 36 were still maintaining radio communication. Lady Liberty was one of them. At 11:12, they crossed the German coast, heading out over the Baltic Sea. The clouds were solid below them, unbroken gray from horizon to horizon. No visual reference, no way to navigate except by dead reckoning and radio bearings. The formation was breaking apart. Aircraft with functioning radios stayed together, following navigation updates. Aircraft without radios were on their own, flying by compass heading an estimated time, hoping to reach England before fuel ran out. Morrison watched 3 B-17s peel away from the formation, heading southwest instead of west. Their radios were dead. They couldn't hear the navigation corrections. They were flying the wrong heading, would end up over the North Sea far from any friendly bases. He tried to transmit to them. "Aircraft at our 7 o'clock, you're off course. Turn right to heading 270. No response. They kept flying southwest, disappeared into the clouds. At 11:47, Lady Liberty's number 3 engine started running rough, oil pressure dropping. Hayes throttled it back, tried to compensate with the other 3 engines. Morrison calculated fuel consumption. They had enough to reach England if the engine kept running at reduced power. If it quit completely, they'd be marginal. 20 minutes later, the engine seized. Hayes feathered the propeller, shut down the fuel flow. Now they were flying on 3 engines. Fuel consumption increased, altitude slowly decreasing. Morrison contacted RAF Coastal Command again, provided their position and status, 1 engine out, 24 aircraft in formation, estimated fuel state. The RAF operator informed Bassingbourn. Base operations responded, weather at Bassingbourn was now below minimums for landing. All aircraft should divert to RAF docking, a coastal airfield with better weather. Morrison relayed the diversion order to Hayes, then transmitted to the other 6 bombers still maintaining radio contact. All aircraft divert to RAF docking, weather at home base below minimums. 6 aircraft acknowledged, changed course for the diversion field. But 29 B-17s had no radio communication. They couldn't hear the diversion order. They'd keep flying toward Bassingbourn, arrive to find the field closed by fog, wouldn't know where else to go. At 13:18, Lady Liberty crossed the English coast with fuel gauges showing reserves nearly exhausted. They landed at RAF docking with 7 other B-17s, the only aircraft from the formation with functioning radios. Morrison climbed out of Lady Liberty, looked around the airfield. 7 aircraft out of 36. Where were the others? Over the next 4 hours, the answer emerged piece by piece. 12 B-17s made it to other airfields, landed with varying degrees of damage and fuel exhaustion. 4 aircraft ditched in the North Sea when they ran out of fuel searching for bases in the fog. Rescue operations recovered 2 crews. 8 men drowned. 13 B-17s crashed attempting instrument approaches in 0 visibility. Some crews survived, many didn't. By 1800 hours, the final count was established. 36 aircraft had launched. 23 returned. 13 were lost. 73 men killed or missing. Of the 23 aircraft that returned, Morrison learned that 17 had his waterproofing modifications. 6 had standard radios. The 17 modified aircraft had 0 radio failures. The 6 standard aircraft had experienced degraded radio performance, but not complete failure. They'd been lucky with atmospheric conditions. Of the 13 lost aircraft, all had standard radios. All had experienced complete radio failure. Without communication, they couldn't receive the diversion order, couldn't get updated weather, couldn't call for emergency assistance. They flew blind into fog and died because they had no radio. The mathematics were stark. Aircraft with modified radios, 0% losses. Aircraft with standard radios, 35% losses. That night, Captain James Tucker, squadron commander who'd lost 4 aircraft from his squadron, confronted Major Bradford at the operations building. Morrison wasn't present but heard the story from multiple witnesses. Tucker, normally soft-spoken, was shouting, 13 aircraft, Major, 73 men, dead because their radios failed, and you ordered Morrison to remove the modifications that would have saved them. Bradford tried to explain regulations, unauthorized modifications, proper procedures. Tucker cut him off. I don't give a damn about procedures. Morrison's modifications work. Aircraft with his waterproofing came home. Aircraft without it died. That's the only thing that matters. Bradford held his ground. I can't authorize field modifications to classified equipment without approval from, then get approval. Or I'll go over your head to group commander. I'll go to division if necessary, but I'm not sending more men to die because you're worried about regulations. Bradford filed a report that night, detailed Morrison's unauthorized modifications, the performance data, the loss statistics. Sent it to 8th Air Force Headquarters with a recommendation, authorize immediate implementation of waterproofing modifications on all B-17 radio equipment. The response came back in 48 hours. A colonel from 8th Air Force Communications arrived at Bassingbourn on October 28th. He inspected Morrison's modifications on Lady Liberty, examined the gaskets, the waterproof compound, the drainage system, tested the radio equipment, interviewed Morrison about the design and installation process. Then he called a meeting with Bradford, Tucker, and Morrison. The colonel got straight to the point. Sergeant Morrison's modifications are effective and necessary. I'm authorizing immediate implementation across all bomber groups in 8th Air Force. Sergeant Morrison will be temporarily assigned to my staff to train installation teams and supervise the modification program. Bradford started to object. The colonel cut him off. Major, your concerns about unauthorized modifications are noted, but this modification is now authorized by me, which means your objections are irrelevant. Sergeant Morrison has identified and solved a critical problem. The Army rewards that kind of initiative, not punishes it. Morrison was reassigned to 8th Air Force Headquarters on October 30th. His job, train mechanics and radio technicians on waterproofing installation, develop standardized procedures, supervise modifications on 2,400 B-17s operating from bases across England. The work was exhausting. Morrison spent 12-hour days traveling between bases, training installation teams, inspecting completed modifications. He refined the process, developed better materials, created technical manuals that any mechanic could follow. By December 1943, 800 B-17s had waterproofed radio equipment. By February 1944, 1,900 aircraft. By April 1944, every heavy bomber in 8th Air Force, B-17s and B-24s, had Morrison's waterproofing modifications installed. The impact was measurable and immediate. Radio failure rates dropped from 35% to less than 4%. Aircraft losses attributed to communication failures fell by 87%. Bombers could maintain contact with bases, receive navigation updates, call for emergency assistance. The modification that Morrison had designed in a notebook during combat missions, that he'd installed illegally on 17 aircraft, that he'd refused to remove despite direct orders. That modification became standard equipment on 6,000 heavy bombers and saved an estimated 400 to 600 crew members' lives over the remaining year of the air war in Europe. Morrison never flew another combat mission. The Army kept him at headquarters, working on communications improvements, consulting on equipment problems. He was promoted to technical sergeant, then master sergeant, received a commendation for technical achievement, got mentioned in reports, but he never got credit publicly. The waterproofing modification was classified. The Army didn't want to publicize that standard radio equipment had been inadequate, that an NCO had identified the problem and fixed it without authorization, that hundreds of men had died before the fix was implemented. The war ended in May 1945. Morrison was discharged in August with the rank of Master Sergeant, a Bronze Star for meritorious achievement, and a stack of official documents he wasn't allowed to discuss. The waterproofing modifications remained classified until 1952, when the technical specifications were declassified and incorporated into public military maintenance manuals. Morrison returned to Pittsburgh, went back to electrical engineering work at Westinghouse. He never talked about the war in detail. When coworkers asked, he'd say he was a radio operator. Fixed some equipment problems, that's all. But the modifications lived on. During the Korean War, B-29 bombers flying long-range missions over water used radio waterproofing techniques derived from Morrison's designs. During Vietnam, Air Force transport aircraft operating in tropical conditions with extreme humidity employed similar moisture protection systems. The principle Morrison had established, equipment needed physical protection from environmental moisture, not just better maintenance, became standard practice in military aviation. In 1968, Morrison received a letter from a man named Robert Hayes, the pilot who'd commanded Lady Liberty. Hayes had tracked Morrison down through veteran registries. He'd spent 23 years wanting to thank the man whose radio modifications had saved his crew on October 25, 1943. Hayes explained that after the war, he'd obtained the mission reports from that Baltic Sea raid. He'd studied the loss statistics, traced the fate of every aircraft. Every single bomber lost that day had experienced complete radio failure before going down. Every aircraft that made it home had either Morrison's waterproofing modifications or had gotten exceptionally lucky with weather conditions. Hayes wrote, "Your unauthorized modifications saved my crew, saved 17 other crews that day, saved hundreds more over the next year. You broke regulations to do it, and you were right to break them. Men like Major Bradford follow rules. Men like you save lives. Thank you for having the courage to do what needed doing." Morrison kept the letter. Never showed it to anyone, but read it occasionally when doubts crept in about decisions he'd made during the war. In 1973, a military historian researching 8th Air Force operations found references to Morrison's waterproofing modifications in declassified documents. The historian tracked Morrison down, requested an interview. Morrison agreed, met for 3 hours, explained the technical details of the modifications and the circumstances that led to their development. The historian asked if Morrison had been bitter about the initial resistance from officers like Bradford. Morrison said no. Bradford had been doing his job, following procedures, trying to maintain order in a chaotic situation. The system had worked eventually. The modifications were tested, approved, implemented. That was what mattered. The historian asked if Morrison felt he'd gotten adequate recognition for his contribution. Morrison thought about it, then said recognition wasn't why he'd done it. He'd watched men die from preventable equipment failures. He'd had the knowledge and skills to fix the problem. The choice was simple: fix it or watch more men die. Recognition was irrelevant. The historian's research was published in a military aviation journal in 1974. The article documented Morrison's modifications in technical detail, included photographs of waterproofed radio equipment, cited mission reports showing the impact on survival rates. The article called Morrison one of the critical but overlooked contributors to bomber crew survivability in the European theater. Morrison read the article once, filed it away, went back to his life. He retired from Westinghouse in 1978 at age 66, spent his retirement restoring antique radios, teaching electronics to grandchildren, volunteering at a local science museum. In 1989, the Smithsonian National Air and Space Museum was developing an exhibit on B-17 operations. A curator contacted Morrison, asked if he'd be willing to loan any materials related to his service. Morrison provided his original notebook, the one where he'd sketched waterproofing designs during combat missions, along with photographs and technical drawings. The curator asked if Morrison had any of the actual waterproofed radio components. Morrison said no, but he could build a demonstration model if the museum wanted one. The curator said yes. At age 77, Morrison spent 2 months in his garage workshop reconstructing the waterproofing modifications exactly as he'd built them in 1943. He machined rubber gaskets, mixed waterproof compound using the original formula, fabricated drainage systems. When finished, he had a complete SCR-274N radio system with all modifications installed, functionally identical to the equipment he'd put in Lady Liberty 46 years earlier. The museum displayed Morrison's demonstration model in their B-17 exhibit. A placard beside it read, "Radio waterproofing modification developed by T. Sergeant Daniel Morrison, 381st Bomb Group, October 1943. Originally unauthorized, this field modification addressed critical moisture infiltration problems affecting bomber communications. Implemented across 8th Air Force, 1943 to 1945. Credited with preventing hundreds of radio failures and contributing to survival of an estimated 400-600 crew members." The exhibit opened in 1990. Morrison attended the ceremony with 3 other men who'd flown in his crew on Lady Liberty. They stood in front of the display, looking at the radio equipment Morrison had modified 47 years earlier to keep them alive. Frank Chen, the top turret gunner who'd helped install the first modifications, said quietly, "You know how many people walk past this display without stopping? Hundreds. They all want to see the aircraft, the guns, the bombs. Nobody cares about a radio." Morrison nodded. "That's fine. The radio operators care. That's enough." And they did care. Over the years, Morrison received letters from former radio operators who'd used his waterproofing modifications during the war. Men who'd maintained communication when other aircraft went silent. Men who'd called for help when damaged and got rescued because their radios worked. Men who'd navigated through weather when other bombers got lost because their radios failed. One letter came from a man named Michael Torres, who'd been a radio operator with the 303rd Bomb Group. Torres wrote that on a mission to Berlin in March 1944, his bomber had been severely damaged by flak. 2 engines out, hydraulics failing, fuel leaking, wounded crew. They'd been 400 miles from England with no fighter escort and German fighters circling. Torres had transmitted an emergency call on his waterproofed radio. The signal reached a P-51 fighter group returning from escort duty. The fighters had diverted, driven off the German aircraft, escorted the damaged bomber back to England. The entire crew survived. Torres wrote, "Your modifications kept my radio working when every other system in that aircraft was failing. That transmission saved 10 lives. I never got the chance to thank you during the war. I'm thanking you now, 50 years later. You made a difference that mattered." Morrison kept that letter too. Kept all of them. A box full of correspondence from men whose lives had been affected by equipment he'd modified in violation of regulations because he believed saving lives mattered more than following rules. In 2004, the 8th Air Force Historical Society invited Morrison to their annual reunion. He was 92 years old, too frail to travel, but he sent a video message. In it, he said, "I wasn't a hero. I was a radio operator who got tired of watching men die from equipment failures. I had the knowledge to fix the problem, so I fixed it." That's what engineers do: identify failures, develop solutions, implement them. The fact that I had to break regulations to save lives says more about the regulations than it says about me. If there's a lesson from my experience, it's this: when you see a problem killing people, fix it. Don't wait for permission. Don't wait for perfect solutions. Don't wait for someone else to act. Fix it with what you have, where you are, as best you can. If you're wrong, accept the consequences. But if you're right, you'll save lives. That's worth any risk. Morrison died in 2006 at age 94. At his funeral, 7 men attended who'd flown missions with waterproofed radios during World War II. None of them had met Morrison personally during the war. They'd been in different bomb groups, different squadrons, but they'd all used equipment he'd designed. One of them, a retired colonel who'd been a radio operator with the 91st Bomb Group, placed a small metal object on Morrison's casket. It was a waterproofed radio connector, carefully preserved for 63 years. The colonel said quietly, "This kept my radio working on 28 missions. Thank you for giving me the equipment I needed to survive." Morrison's family donated his papers, photographs, and demonstration radio equipment to the Air Force Museum at Wright-Patterson Air Force Base. The materials joined thousands of other artifacts documenting aviation history. Not the dramatic stuff, not the aircraft or weapons that visitors came to see, but the technical innovations that made those dramatic things possible. In 2015, a graduate student researching World War II communication systems found Morrison's papers in the museum archives. The student was writing a dissertation on field modifications and their impact on military effectiveness. Morrison's waterproofing modifications became a case study. The dissertation documented that Morrison's modifications had been installed on approximately 6,000 heavy bombers between October 1943 and May 1945. Radio failure rates dropped from 35% to 3.8% after implementation. Aircraft losses attributed to communication failures fell from 47 incidents per month to 6 incidents per month. Based on crew survival data, the student estimated that Morrison's modifications contributed to survival of between 500 and 700 crew members who would otherwise have died in aircraft loss due to radio failures. The numbers were estimates, impossible to verify precisely, but they represented real people. Radio operators who'd maintained contact with bases when other aircraft went silent, navigators who'd received position updates through fog, pilots who'd called for help when damaged and got rescued, crew members who'd made it home because their bomber could communicate. The dissertation was published in 2016. It included Morrison's original sketches, technical specifications, mission reports, and interviews with surviving crew members who'd used the waterproofed radios. The conclusion stated, Morrison's unauthorized field modifications represent a paradigm case of adaptive innovation under combat conditions. By identifying equipment failure patterns, developing practical solutions, and implementing modifications despite regulatory prohibition, Morrison demonstrated that effective innovation often requires willingness to accept institutional risk in service of operational necessity. Academic language for sometimes you have to break rules to save lives. Morrison never read that dissertation. He'd been dead for 10 years when it was published. But his modifications lived on in military doctrine, technical manuals, engineering practices. The principle he'd established, that environmental protection of electronics requires physical modification, not just better maintenance, became standard in military systems design. Modern military radios use hermetically sealed housings, waterproof connectors, moisture barriers, drainage systems, all descended from concepts Morrison developed in 1943 using rubber gaskets, electrical compound, and a drill. Today, at the National Museum of the United States Air Force, Morrison's demonstration radio sits in an archive storage facility, not on display, too technical, not visually interesting enough for public exhibit, but preserved for researchers studying innovation, field modifications, the gap between official specifications and operational reality. Next to Morrison's radio in the archives sits a folder of letters. 53 letters from former bomber crew members, thanking him for equipment that kept them alive. Letters spanning 6 decades, from 1946 to 2005. Letters from radio operators, pilots, navigators, men who'd survived missions because their radios worked when it mattered most. That's the real story of military innovation. Not dramatic breakthroughs or revolutionary technologies, just a sergeant who noticed a problem, designed a solution, implemented it without permission because waiting for approval meant watching more men die. Every radio operator who transmitted an emergency call through waterproofed equipment owed that capability to Morrison. Every crew that received navigation updates through fog owed their survival to modifications he'd built. Every bomber that made it home because its radio functioned when others failed owed that success to a man who believed regulations were less important than lives. If this story resonates with you, hit that like button. It tells YouTube to share these forgotten histories with more people. Subscribe so you never miss the stories of people like Daniel Morrison, the problem solvers, the rule breakers, the men who saved lives without seeking recognition. Leave a comment. Tell us where you're watching from. Tell us if someone in your family served in bomber crews. Tell us about the technical innovations that don't get headlines but make everything else possible. Thank you for watching. Thank you for remembering. Thank you for keeping Daniel Morrison's story alive. These men deserve more than silence. They deserve to be remembered for what they actually did, saw problems, fixed them, saved lives. That's the real heroism of war.